Hi, today we're going to learn about the introduction to Python. This workshop is for students with no exposure to Python before. Before we move on to the lecture, all of our workshop materials are accessible on our GitHub repository. Here's the link to the GitHub repo, and you can pause this video to type this in the browser. The link is in the description of the video as well. Now we'll begin our introduction to Python workshop. We'll be using Google Colab to demonstrate the use of Python. Google Colab is an online notebook that allows you to combine executable code and rich text in a single document. To follow along with this workshop, we highly recommend you visit the Google Colab website. Once you access the Google Colab website, you will be able to create a new notebook. To use the demo notebook from the Data Visualization Lab, click the GitHub tab on the top and paste the following link. And click the magnifier icon, or to create a blank notebook, click a New Notebook button at the bottom right. When you finish creating a new Colab notebook, there are two types of cells in this notebook, a code cell and a text cell. A code cell is a cell where you can write your Python code and execute it cell by cell by clicking the play button on the left side. A text cell is where you can write notes, section titles, or instructions in the notebook. Once you enter a text content in the text cell, you can simply click the Close Markdown Editor button on the right top of the cell, or click Shift and Enter together. We just finished setting up the Google Colab notebook. If you have any questions regarding the Google Colab, please visit the Google Colab website. Now we are going to introduce why we're using Python, simple variable types and operators of Python, different collections of data, conditional statement, and iterative loops. To begin with, Python is a general-purpose programming language well known for being one of the most versatile and easy-to-use languages. It has simple syntax close to human language, making it easy to learn and read. Owing to its usability and versatility, Python is great for prototyping and quickly writing working code. Its popular use include mathematics and big data handling and data visualization with various packages available for specific purposes. So, how does Python allow this simple scripting and quick prototyping? First, we need to know what data types are available in Python. A variable is a container for storing data values. Depending on what data a variable contains, it can have different variable types, and we are going to look at 4 atomic types of variables: integers, floats, strings, and booleans. Python is a dynamically typed language, which means you do not have to declare variable types. It can even change the type after it has been assigned a type. To give a value to a variable, we use the equal sign. Put a variable to create or assign value to the left side of the sign, and put a value on the right side. It is better to use comprehensible names, which makes readers easier to understand. From here, we'll move on to a section where we'll be running code cells. Make sure to run every code cell in the demo, since some variables will be used in the later sections. The first type is integers. Integers are positive or negative numbers without decimal places. Once we assign a value to a variable, we can print the assigned value on the screen using the print function. Inside the print function, you can put any object that you want to print its value. In this case, we are printing an integer value stored in the variable aint. The print function is often used to check the value of a variable to see if we have correctly assigned the desired value. The second type is floats. Floats are floating point numbers with decimal places. The next type is strings. Strings are a sequence of characters surrounded by single or double quotation marks. To access one or more characters in a string type variable, we can use square brackets and the index. The index of a string starts from 0, which is the most left character in a string variable. If we use a negative index, then -1 indicates the most right character of a string. And you can also slice a partial string from another string using a range of indices using a colon. The last type is booleans. Booleans are true or false values. Boolean types are often used in conditional statements, such as checking if a variable is a specific data type or if an integer is a particular number, and so on. For example, if we assign hello to a variable a string and check if it is hello, we can use two equal signs to compare two values on each side. We are using the two equal signs to check if the string is assigned correctly as we wanted, which is hello for a string here. There is also a non-type variable when a variable exists but there is no value in it, not even 0. This is helpful in more advanced programs to check whether the passed variable is not empty. As we look through the 4 basic variable types of Python, we can also see the types of a variable using the Python built-in type function. We'll take a look at all the variables and their types we have assigned so far. Before we move on to the next section, there are a few rules you have to follow in naming a variable. In Python, you cannot start a variable name with numbers, and you cannot have a space in a variable name. We commonly use underscore to enhance the comprehensibility of variable names. A few naming conventions are widely used, but the general rule is to start a variable name with a lowercase letter and keep them descriptive, like including its type in it. Now we'll move on to the operators of Python. The operators in Python let us do things with variable and their values. We have already seen an operator, the assignment operator, which is the equal sign. Besides the equal sign, there are operators used for addition, subtraction, multiplication, division, modulo, exponentiation, comparisons, and Boolean operations. To begin with, the plus sign is an operator that adds numerical values or concatenates string values. In this cell, you can see the two variables that contain numerical values, aint and afloat. When you add them together using the addition operator, the return value is a float and gives their numerical sum. If we add two integer values, like the second line, then the return value is also an integer, and you can see their numerical sum. You might have wondered what the pound character does and what those green texts are. Anything that comes after a pound on the same line is a comment. It is not executed, just ignored by Python, but it enhances our readability. It is handy in some coding environments without a text cell, whereas in Google Colab we can just add notes in text cells. The plus sign can also concatenate string values. We can concatenate two variables containing string values, or either one can be a string value itself, or both can be string values. The concatenation using the plus sign will not add any white space between the two, so we can manually add a space, a tab, or a new line between them. This \n is a type of white space, and there are \t for a tab and a space. As you can see, the 4 concatenations have different results depending on what we concatenate together in the middle. However, we cannot mix and match strings and numerical values. If you try to add an integer and a string, Python will raise an error. To add them, we can simply cast the numerical values to string values using Python built-in typecasting functions. Using the name of a variable type like string, int, float, and bool, we can change the variable type. We can revisit this type function to check the variable types here. We can now add the values with other strings using typecasting. The next operator is a subtraction operator. It works the same way as an addition, but only works with numerical values. We can subtract the same numerical type values and a float from an integer and vice versa. However, we might sometimes encounter a weird value while handling float values. In this cell, when we subtract 6 from 6.6, it seems like we should have a neat value of 0.6, but in reality, Python returns a very close value to 0.6. This is not a bug, but a floating point precision error typically resulting from Python handling floating points. For now, we can ignore this part. However, when you want to handle data with higher precision, you can use other mathematical extensions of Python. We'll move on to the next operators. You can either use floating point division or integer division operator depending on the desired result value. The floor division operator returns floor value for both integer and floating point arguments. The modulo operator returns a remainder of dividing two numbers. The operators returning Boolean values are comparison operators and logical operators. The comparison operators compare two values. Depending on the condition, it either returns true or false. In the example code cell, only the second, third, fifth, and sixth line are true, and the rest are false. The is operator is also used to compare its left and right, but it checks if they are the same object. When you compare an integer and a string variable, they are not the same object, so the first print function displays false on the screen. On the other hand, because int a and int b are referring to the same integer value, 1, it returns true. There are logical operators as well. The OR operator's result is true if either one is true. The AND operator's result is true if both are true. Finally, the NOT operator's result is flipped value of a Boolean value. You can pause anytime to look up terms or concepts online. Often, we'll be working with many numbers and we need some way to arrange those numbers that make sense. Python has a good range of collections to help us with this, the four most helpful being sets, lists, tuples, and dictionaries. The first collection is a set. Sets are just like sets in math, a group of information that is non-ordered and does not contain duplicates. To create a set, we can initialize an empty set using set parentheses. Or to make a set containing values, we use bracelets and put values in it. Adding more elements to a set can be done with .add function. The second line will not change the set because dog is a duplicate of an existing value in the A set. We can print the elements of the sets using the print function. An operator in can be used to check if the element is in our set and returns true or false. In this case, because dog exists in the A set, this line returns true. However, the same code returns a different value when we delete dog from the set. This removal can be done with .remove function. The exact same line of code returns false after we remove dog from the set. The next collection of data is a list. Lists store value in order and can contain different types of values. To initialize an empty list, we can use list parentheses or brackets. To make a list with values, we use brackets and put values in them. As we access string values with indices, we can also do the same indexing with lists. To access the first element, we start from index 0. This index 2 will return the third item in the list. To add values to a list, we can use the .append function to append a new value to the end of the list and the insert function to a specific location in the list. When we execute the following code, you can see that mouse has been appended to the list at the end and hello has been inserted to the fourth place in the list. To remove an item from a list, we can use remove function. However, the remove function is not the only way to remove an item. A pop function also removes a value at a specific location and returns the removed item. If we don't specify the index, it removes the last element, which is the most right element of the list. When we're using remove function, it only deletes the first occurrence of the item if there are more than one of the same values. The third collection is a tuple. Tuples are another group of ordered data that are not mutable. Sometimes we need to keep important values, not losing any of its elements, like storing the ID and password, and that is when tuples are used over lists. For example, since we cannot change the existing tuple, if we want to add more values to it, we need to make a new tuple. Accessing elements of a tuple is just like accessing each character in a string or an element in a list. So if we add cat and another dog to a tuple, we simply access every element of a tuple using indices while putting new values in its position. The last collection of data is a dictionary. Dictionaries store information in key-value pairs. It lets us associate data with other data rather than just an index. To initialize an empty dictionary, we can use dict parentheses or curly bracelets. To make a dictionary with information in it, we can initialize it like a dict. To add more key-value pairs, define a new key after a dictionary name and assign a value to it. If the key already exists in the dictionary, then the value is overwritten by a new value that we assign. Let's print out all three versions of the a dict. We can see its initial form when a new key is added and when the existing value is changed. Moving on to the next cell, if we want to know a value of a key, we can access the value using the key. We can assign the value for later usage as well. If we want to see all the keys or values, we can use .keys or .values functions. To remove a key-value pair, we use .pop here too. By specifying the key we want to remove, it deletes the corresponding pair, both the key and the value. We can store collections of data in another collection. For example, if I store information on students in different dictionaries, I can arrange all the students in a list. Okay, before we move on to the conditionals, until this point, we've been writing code beginning at the first space of a line. However, in conditional statement and iterative loops, we will need indentation of code blocks. We'll talk through the details of the indented code blocks as we proceed to the conditionals. Conditional statements are used to execute a particular command only if certain requirements are met. The basic conditionals are if, elif, and else. Ifs come at the beginning of a conditional code block, and elif and else follows if. When conditions of if are met, elif and else is skipped. However, when the conditions are not met, then we move to the next elif or else statement and check its condition. Elif and else are not required. At the end of the if statement, the colon indicates that the following lines of code will be a nested block of code. Take a tuple as an example. We've looked into the in operator that checks if an element exists in a tuple that returns a Boolean value. The first line, if, will check if the condition is true. Because there is a dog in the a tuple, this statement is a true. Because the condition is met, the code block inside the if is executed, it will print bark. The elif and else conditionals will not be evaluated in this case because if statement did not fail. In the following example, the first if statement condition is true, printing bark, and another if that is also evaluated. However, there is no mouse in a tuple, which will not execute a code block under this if statement. Instead, it will move on to the else statement and print I am not a dog or a mouse. The else statement belongs to the if statement directly above it, independent of the first if statement. A powerful tool of Python is loops. They can execute a block of code number of times until a particular condition is met. For loop is used to iterate over elements of a sequence. The sequence can be a tuple or a list or a range of integers. We can execute a set of statements once for each item in the sequence with the for loop. In the example code, we iterate over each element of the list. We name the iterator item in this for loop to execute the print function for each element. For loops are commonly used with the range function. The range function generates a series of numbers using its specified starting and ending value. This function can take 1, 2, or 3 values, which serves as a starting value, ending value, and the size of each step. To demonstrate the usage of the range function with a varying number of values passed to it, we will take a look at the following code cells. When we give only one value to the range function, the value is the stopping value, which is exclusive. In this case, it will start at 0 and ends at 4 because 5 is the stopping value but exclusive. The next cell is an example of passing two values, which serve as a starting value and the stopping value. It will start from 1, ends at 4 since 5 is also the stopping value but exclusive. The last cell is an example of passing three values specifying starting, stopping, and step values. This range function starts at 1, incrementing 2 until it reaches the stopping value. To use this in real-world cases, we will first look at len method. It returns the length of a list, string, dictionary, or any other iterable data format in Python. If we use the len method on a list, it returns the number of items in the list. If you take a look at the code cell, we use the length of a list to use it as a stopping value of a range. The for loop will iterate over the series of integers generated by this range function and use the integer to access each element of a list by index. This is slightly different from iterating over each element using the element itself as an iterator. Accessing the elements using indices allows you to do extra operations involving indices. While loop is used to repeat a block of code until it meets a command to break the loop or the condition inside the while loop is met. While loop does the same thing as if statement does, instead of running the code block only once, but repeatedly. They jump back to the point where the code began and repeat the whole process until the condition is met. In this first example, we will make a while loop that does the exact same thing as the above for loop. To track the index and increment it manually, we use a variable I and add 1 at the end of every iteration. Without incrementing the variable I, the loop will run forever. The next example's while loop has a condition to be checked. Whether the item at the index in the list is not a string. As soon as the item at the current index is a string, it exits the loop. We iterate through the list using the variable I, and when it gets to I equals 3, a list index 3 is a string type variable and the while loop's condition is met. We exit the loop. Because anything that evaluates to a boolean can be used as the condition, we can use the boolean value true and have a while loop run forever. We can use the command break if we need to get out early, always bringing you out of the most recent loop. In this example, the variable I starts at 0. It is incremented by 1 as it iterates over the while loop. And when I becomes 5, it prints the breaking out of the while loop and break. It breaks before I is incremented at the end. You'll notice the difference in incremental code for the variable I. In the previous example, we used I equals I plus 1. The expression of a plus and equal sign together is a shorthand for I equals I plus 1. You can do this with simple addition, subtraction, division, or multiplication that the operation result will be a new assignment of the current variable. So when we meet I plus equal 1, I becomes an integer 1 bigger than the previous value. The break command also works with the for loops. In this example, we iterate over each item in the A list, and when we reach dog for the first time, it breaks the for loop and exits. We've talked about iterative loops so far. You can pause anytime to look up more about the iterative loops or other Python concepts online. Now that we have learned the basics, we're ready for functions. We've already been using them. When we want to use a function, we use the function name parentheses format. So print, range, len, type are all functions Python already built for us to use. Functions are sections of code that are callable, which means it only runs when it is called. By using functions, we don't have to write duplicate code to do the same task over and over again. We can also break down complicated problems into simpler or more straightforward tasks. Parameters are data we can pass into a function for it to use. For example, in this myfuncx, y, x and y are the parameters we pass into the function. The function's goal is to multiply two input numbers and get the result, and we can give two numbers using the parameters. The return statement at the end returns a value from the function. This lets us use the result of the function outside. However, this return statement is optional. It is different from print statement. That print statement shows the value to the screen, but it does not pass over the value of the object inside the print statement. On the other hand, the return statement does not display anything on the screen. It lets other lines of code or functions use the value. For example, by storing the return value of myfunc2, 4, the print function can use the value to display it. There is a print statement inside the function, so when you run myfunc2, 3, the multiplication of 2 and 3 is 6, which is greater than 0, going into the if statement and printing the result. However, because we did not store the return value 6 to another variable, we cannot use it for another line of code. The following line assigns the function's return value into return val. While running this function, the multiplication of -2 and 4 is less than 0, which will skip the if statement. However, it still returns the multiply result stored in our new variable return val. This return val is used in the print function to display the stored value. Today we have learned pretty much everything of Python basics, from its data types all the way up to crafting a simple function. This is as far as this lesson will go. You can replay this tutorial to get better understanding of the demo and the concepts covered here, or look them up online. Thank you for listening.